Hello everyone, myself Tanzia Mansuri. Currently, I am pursuing Master of Computer Application from International Institute of Professional Studies. I am in ninth semester, and today I am going to present here a topic related to cloud computing, that is grid computing. So let's see what is grid computing, and we will cover all the topics related to grid computing. That is, what is grid computing, what are the uses of grid computing, how the grid computing actually works, what are the environment of grid computing, what are the architecture of grid computing, what are the types of grid computing, and all the small and related topics related to grid computing will be covered in this videos. Okay, so let's get started. What is grid computing? So, grid computing is a type of data management and computer infrastructure which is designed as a support primarily for scientific research, but it is also used in various commercial concepts, business research, entertainment, and by the government of different countries. And now let's see what are the uses of grid computing. So, grid computing can be used by government, for military, for teachers and educators, and for businesses. Now let's see the working of grid computing. So, a grid computing actually, you can see the diagrammatic representation of the working of grid computing, in which we need at least one computer, which usually acts as a server and which handle all the administrative duties for the system, and a network of computer which running on a special grid of computer network software, and a collection of computer software which is called as middleware. Now let's see the typical view of grid environment. A grid environment basically contains of grid resource, grid information system, resource broker, and user. So grid resource is a cluster, PC, supercomputer, database, instrumentation, etc. And what is grid information system? So grid information system contains the detail of grid resources. Basically, it is a system which collects the detail of the available grid resources and then passes it to the resource broker. And then the resource broker distributes the job in an application to the grid resource based on the user's QoS requirement and details available on the grid resource for further execution. And then the user sends computational or data intensive application to global grid in order to speed up the execution of the application. Now let's see the security mod. And now let's see the architecture of grid computing. So grid architecture contains of five layers, which is fabric layer, connectivity layer, resource layer, collective layer, and application layer. Fabric layer provides the resource to which shared access is mediated by grid protocol. Connectivity layer defines the core communication and authentication protocol required for grid-specific network function. Resource layer defines protocol APIs, SDK for secure negotiation, accounting, payments, and sharing operation. And collective layer contains protocol and service that capture interaction among a collection of resources. Application layer are user application that operates within the VO environment. Now let's see grid security model. So this is basically a representation of grid security model. You can go through it once. Let's move towards the type of grid. Grid computing grids are basically of three types: computational grid, scavenging grid, and data grid. Let's see each one of them one by one. A computational grid focuses on setting aside resources specifically for computing power. In this type of grid, most of the machines are high performance server. A scavenging grid is most commonly used with large number of desktop machines in which machines are scavenged for available CPU cycle and other resources. And owner of the desktop machine are usually given control over when their resources are available to participate in the grid. Uh, Data grid. Data grid is responsible for housing and providing access to data across multiple organizations in which users are not concentrated with where this data is located as long as they have access to the data. Now, grid computing is basically a computational grid, cousins of grid computing, and a method of grid computing. We will see each topic one by one. Computational grid, it is a network of geographically distributed resources which include computers, peripherals, switches, instruments, and data. And each user should have a single login account to access all the resources, and resources may be owned by diverse organizations. Mm, In computational grid, they are managed by gridware. Now, what is gridware? So, gridware can be viewed as a special type of middleware that enables sharing and managing grid components based on the user's requirements, source, and attributes. What are the cousins of grid computing? So, cousins of grid computing are parallel computing, distributed computing, and peer-to-peer computing, and some others such as cluster computing, network computing, cloud server computing, internet computing, and so on. Distributed computing. In distributed computing is most often concerned with distributing the load of a program across two or more processes. In peer-to-peer computing, peer-to-peer computing is basically sharing of computer resource and service by direct exchange between the system, in which one computer acts as a client and the other acts as a server, which depends on the role which is most efficient. Now, the methods of grid computing are distributed supercomputing, high throughput computing, on-demand computing, data-intensive computing, collaborative computing, and logistic computing. Distributed supercomputing combines all multiple high-capacity resources on computational grid into a single virtual distributed supercomputer. It tackles the problem related to a single system. High throughput computing uses the grid to schedule large number of loosely coupled or independent tasks with the goal of putting unused processor cycle to work. On-demand computing uses grid capabilities to meet short-term requirements for resources that are not locally accessible and models real-time computing demand. Data-intensive computing focus is on synthesizing new information from data that is maintained in geographically distributed repositories, digital libraries, and databases. It is particularly useful for distributing data mining. Collaborative collaborative computing concerns primarily with enabling and enhancing human-to-human interaction. Applications are often structured in terms of a virtual shared space. Logical network is a global scheduling and optimization of data movement, contrast with traditional network which does not explicitly model storage resource in the network. It is called logistic because of the analogy it bears with the system of warehouses, depots, and distributed channels. Now let's move toward the advantages and disadvantages of grid computing. Advantages of grid computing is it increases the user productivity. It provides scalability and flexibility. It increases user productivity by providing transparent access to resources which works with and through which the work can be completed more quickly. Scalability means a grid can grow seamlessly over time, allowing many thousands of processors to be integrated into one cluster. Flexibility, grid computing provides computational power where it is needed most, helping to better meet dynamically changing workloads. Let's move toward disadvantages. For memory-hungry application that cannot take advantages, you may be forced to run on a large system. So basically, disadvantages of grid computing is you have to run this on a large system. In this, you require a fast interconnection of computer resources such as gigabyte Ethernet, and some application may need to be tweaked to take full advantage of new model. And for many servers, we also need a license which is prohibited by the some apps and vendors. In a conclusion, we can say that grid computing introduced a new concept to IT infrastructure because it supports distributed computing over a network of heterogeneous resources and is enabled by open standard. Now let's move towards the questions section. Here are the listed 10 questions based on the PPT. Let me go through each question one by one. First question is what is the main purpose of grid computing? Second question is can you name a few industries that benefit from grid computing? Third is what is the role of the connectivity layer in grid architecture? Four is what is the data grid difference from a computational grid? Fifth is what is gridware and why is it most important in managing grids? Sixth is how data scavenging grid computing utilize ideal resources. Seventh, what are the key differences between distributed computing and grid computing? 8. What types of grid computing method is best suited for tasks requiring immediate resource? 9. What are the main advantage of grid computing? And 10. What is one challenge you might face when implementing grid computing? So these all are the questions based on the PPT. You can go through it and try to answer it yourself. Thanks